So this is good evening everyone. This is lecture number 9 and we are dealing with reflection. In about 2 or 3 more classes we should be done with this chapter because we'll have to cover all types of questions that can be asked, and we are on the verge of doing finishing all types of questions. The one type of question remains, so we will deal with them. We will try to cover as many things as possible. Remember, whatever we do, we must do it to such a level that any question that comes, you should be able to solve it. And if I'm not correct, what we were discussing in the last class is on your screens right now. We were discussing where is the image formed when object is placed at different positions. And this is one thing that you should never forget. I hope you remember this, all these 6 positions, yes or no? We all remember these 6 positions. Where is the image formed? We have noted this down, yes or no?
Yes,
Are?
sir.
Say na, yes. Yes,
Yes,
we have
sir.
noted this down. Yes, we have noted this down. Now remember, whatever I am telling you, it's of utmost importance, and you must keep in mind that point, because any of these points which we are discussing may come as direct or indirect
Sir,
questions.
you didn't say us convex.
Yes, beta? No,
You
I'm
didn't
not.
explain.
I did not miss anything. Trust me. Trust me. Have faith on my abilities, yeah. When I say that we are done, then you say, sir, you missed that. I'm not done yet. I have a long innings to play. I am a test match player. I don't hit sixes. I just keep on grinding the bowling and moving ahead. Let us now, since we have discussed concave mirror, let us summarize it up in terms of important points. Now I'll say the same things, but I will say them probably in a different way. Now let us see if we can memorize them in this way. For real object, now whatever cases we have done, these 6 cases, what type of object we were dealing with? Was it a real object? For real, this is because one class cannot speak. This is real and this is virtual. Okay. So what type of object we were dealing with? Was it a real object or was it a virtual object?
Real object.
Yes. So the class that can speak real. The other class can just tell me thumbs up. That means we were dealing with real objects. Now, that is what I'm going to write for real objects. Real O. And we are talking the case of a concave mirror. Remember that we only have done concave mirror, we have not done convex. What type of image a concave mirror can form if the object is real? And that is the answer that I asked from you. What is the type of images a concave mirror can form for real objects? Yes.
Inverted image.
Hey, what is an inverted image, yaar? I never said that an image is inverted. Object is real, image is. There are 2 types of object, 2 types of image. Inverted and erect is how they are standing, whether they are standing like this or like this. That is not the issue. There are 2 types of object and 2 types of image. Right. Yeah. Say again.
Real image and virtual image.
Yes. That is what you need to understand. For a real object, a concave mirror can form both the images, whether the image is real, whether the image is virtual. Do we understand this? We have seen this thing in the different cases that we have seen. Yes or no? We understand this. Can I have raised hand that we understand this?
Yes, sir.
Concave mirror can form both sides of image. Now, remember these points. Now, if the image is real, it can have all types of magnification. Magnification can be less than 1. Magnification can be equal to 1. Yeah, the noise has gone. And the magnification can be greater than 1. So, for a concave mirror, it can form real images of real objects, and the magnification can be anything from infinity, from 0 to infinity. When is the magnification less than 1? Tell me. When is the magnification less than 1?
Image at infinity.
When is the magnification less than 1? Image is at infinity. What are you saying? When is the magnification less than 1?
Object at infinity.
Only that point? No other point? That means you have not remembered all those 6 positions. That means the last class is a total waste. When the object distance u is greater than 2f, the object is placed beyond the center of curvature. Do we understand this? Array, say yes or no.
Yes,
Either it's a
sir.
yes or it's a no. It cannot be no answer. Do we understand this? I am writing the
Sir.
same thing in a different way because it may be asked in this way. So, magnification would be less than 1 when u, object distance, is greater than 2f. When it is equal to 1,
Equal to 2f.
yes, u is equal to 2f. This is the way you can remember it now. Same thing can be asked in different ways. Well done, my dear friends. What about magnification less than 1 or greater
U
than
is
1?
less than 2f.
Yes, u is less than 2f, or I can say u is between f and 2f. Yes or no?
Sir.
F is less than u is less than 2f. Well done. Now let us talk about what happens when the mirror forms a virtual image of the real object. There's only one case where it does. Which one is that case? Where it forms a virtual image.
It's less than f.
U is less than f, and in that case your magnification is always greater than 1. That means a concave mirror, if it forms a virtual image, a concave mirror, if it forms a virtual image, it is always going to be magnified. Do we understand this? It can only form virtual image in one case. That case is when the object is between pole and the focus. And in that case, magnification turns out to be greater than 1. Can you remember this?
Sir.
Object is real. What happens if the object is virtual? Now we will be coming across these virtual objects not for one mirror or one lens. Probably when we have a combination of mirror and lens, then these virtual objects are going to come. For virtual objects, tell me, my dear friends, I have not told you anything about the virtual objects. We have even not drawn the ray diagram of a virtual object. We'll do it, don't worry. For virtual object, what can a concave mirror do? For virtual objects, what can a concave mirror do? What type of image do you think a concave mirror can form for virtual objects? Any idea? Remember it. It can only form real images of virtual objects. For virtual objects, my dear friend, remember a concave mirror can only form real images. This can come as a direct question. This can come as a question which is not direct, but you may have to apply it. And you will never know how are you applying it. But if you remember this, then only you can apply it. We've seen two cases. Then there's an important thing that you can remember. A concave mirror. This is what it can do. Now I'll write it what it cannot do. A concave mirror cannot. Can you complete the sentence? The class which is mute. Can you complete the sentence? The class which can speak. Can you complete the sentence? A concave mirror cannot. What? It's right there on your screen right now in front of you. A concave mirror cannot. If you can complete the sentence, that means you have understood the concept. Yes.
Cannot form virtual image.
It can form virtual image, my dear friend. See, virtual image is here. You have said only 50% and your voice has improved drastically. That the humming noise has gone. Okay, complete. Say the full sentence. A concave mirror cannot. Is right
Form
there
virtual image
with a. Is
Not
there
from
right in front
virtual
of your
image of
eyes?
virtual objects.
Yes, that is correct. It cannot form a virtual image of a virtual object. Whatever you do, wherever you place a virtual object, it can never form virtual image of a virtual object. Do we understand this?
Yes, sir.
We have seen 6 cases, and those all 6 cases were of real images. You will say, sir, we have not seen a case of virtual image, a virtual object. Don't worry. No one is going to ask you the diagram. Whenever question comes, we will see that one as well. Maybe today only we may encounter virtual objects. Is it clear to everyone what we have written? This is all about concave mirrors, theoretically, that you must know.
Yes, sir.
Have you noted it down?
No, sir.
No, sir? Then when will you note down, sir? After the class is over, sir. Please note it down, sir.
Okay, sir.
Okay, sir. Thank you, sir. Note it down, sir. So that I can prepare myself.
Copy it, sir.
Done so quickly. Well done. Your writing speed has gone up tremendously, and that is a good sign. If your writing speed is more, that means you are probably understanding what is going in the class. I hope everyone has noted this
Thank
down.
you, sir.
Can we move ahead in life? Yes, everyone. That takes us to the next position. And since concave mirror is done, we move on to convex mirrors, and there are only 2 positions which are possible. Position number 1, my dear friend, is when the object is at infinity. Very simple. Image will be formed at the focus. We all know it. It will be highly diminished. We can understand this. Remember, object is real and image is going to be virtual, and virtual image is going to be erect. You can see the difference between concave mirror and convex mirror. Concave mirror was able to form real image of real objects. Here we will see what type of images forms. If the object is at infinity, image is at focus, not a real image, virtual image, highly diminished, it will be erect. Have you noted it down? I hope the table is there in your books. Note it down, my dear friends. Shall I move ahead in life? Life has to move on and on and on.
Yes, sir.
Yes, sir. Then, sir, this is the diagram, sir, of an object which is placed at infinity. Rays are coming parallel. Again, the diagram is drawn not for parallel rays which are parallel to principal axis, but rays which are not parallel to principal axis. And as you can see, my dear friends, the image is definitely formed at the focus. The rays are not actually meeting because this ray is going dar like this, and this ray falling perpendicular goes dar like this. They are not going to meet actually, but they are going to meet if you extend them backwards, and therefore we have a virtual image which is highly diminished. Don't need to draw the ray diagram. No one is going to ask you the ray diagram. This is just for you to see, because seeing is believing. When you hear something about something, you may not believe it, but when you see it with your own eyes, you may be able to believe it. Shall we move ahead? Seen the diagram? Yes or no?
Yes, sir.
Then that takes us to the second possible position. And remember, all the pole, focus, center of curvature are on the painted side. So there is only two position possible. One is at infinity, and the second position is you place it anywhere. Doesn't matter. There's only two positions, and either infinity or not infinity. So if it is not infinity, my dear friends, anywhere between infinity and pole, because everything is on the other side, the image is formed between the pole and the focus, my dear friends. Remember where the position is. It is going to be highly diminished, it is going to be virtual, and definitely it is going to be erect. Virtual images of real objects are erect. Do we understand this? Yes or no? No, yes?
Yes, sir.
Or is gone above our head saying bye bye? Bye bye, sir, we are going. Okay. If you have understood this, this is the proof of what I was saying. This is the diagram for position number 2. As you can see, my dear friends, object is placed not at infinity at any other point. Whatever happens, this is the pole, or this is the focus, this is the pole. The image is going to be between pole and the focus. It is going to be an erect image. It is going to be a virtual image, and it is going to be diminished as well. Do we understand this? Have you noted it down everything, bacha?
No, sir. 1 minute.
Are you drawing the diagram, my dear friends? Well, you can draw the diagram. Diagram is what should I say? Not compulsory. It's an optional thing. If you want, you can draw it. No one is going to ask you the diagram as such. The only thing is you must remember the position of the object, position of the image, what type of image is there, and where is the image formed. That is of prime importance, my dear friends. You will not you should not, I will not is the wrong language. You should not forget the what? Position of the object and position of the image. Shall we move further ahead in life? Huh?
Sir.
Okay, sir. Then comes important points. What we had written for concave mirror, the same points will be written for convex mirror. Let us talk about for real objects. And I will not say the complete sentence. I will just write the condition. For real objects, convex mirror can form which type of image?
Virtual.
It is always virtual. Well done, my dear friend. What about the magnification?
Less than 1.
Magnification is less than 1. Well done. Where is the position? Between F and P. Will you remember this, my dear friends? Let us say yes or no. No answer is no answer.
Yes, sir.
Similarly, now if I ask you why I have changed the color of the pen, for virtual objects, now apply some common sense. For a virtual object, a convex mirror. Now we have not drawn the ray diagram for virtual image, but I want you to take some inferences and tell me what type of image can a convex mirror form for a virtual object? You can take the reference of what we know about
Image, sir.
yes, bacha.
Real image, sir.
For virtual object, it can form a real image. Okay. But that thing concave mirror can also do. Convex mirror has to be special. So it can form, for virtual objects, it can form real image as well as virtual image. It can do both. For virtual object, it can do both. What it cannot do? Yes, my dear friends. What it cannot do?
Cannot form real images for real objects.
That is correct. It cannot form real image of a real object. This is the essence of what we were talking about. It cannot form real images of real objects. Can you remember this? If you can remember this for this, then life is going to be very simple when we move ahead.
Sir,
Yes, beta.
one show the ray diagram for second case.
You want to see the ray diagram for the second case?
Sir,
Okay, it's here. What's the problem here? Everything is good? Any doubt? Real object, virtual image between F and P. Shall we move ahead in life? Yes or no? No, yes.
no doubt, sir.
Have you noted down, beta?
Yes, sir.
Tough. Well done, my dear friends. Remember, everything that we are studying is what I call gold dust. So dust made up of gold. Any point from this particular what? Particular discussion is going to come in the examination hall in JEE Main and JEE Advanced, and then I will show you this class car recording, and I'll show you think beta. I told you this. So remember this. Now, coming ahead, many a times, and this you will not find this in many books. They might give you graphs based on U and V and U and M and all these things. So here comes the most important part of this topic, the graphs. How are the graphs for this? And I'll show it to you. Let me put them one by one. One by one it would be. Okay, I'll put them one by one. That would be better so that you can see them. Graph number one. I put two graphs on one page. That would be good. Graph number one, and I hope these graphs you have to draw. There is no escaping this graph. Graph number one, as you can see, this is a graph between what? This is a graph between what? This is a graph between 1 by u and 1 by v. For a concave mirror, and 1 by u plus 1 by v is 1 by f. So graph is a straight line with a negative slope, and the slope of this graph is nothing but, you can find out the slope of this graph, and this is how the graph looks like. This is a straight line graph. Do we understand this? Now remember, whenever we are drawing any graph or anything, it is always, in this case, it is for real objects, it is not for virtual objects. Do we get this? Yes or no? This is the graph. You'll have to draw it. Or any of these graphs can be asked as questions in your exam. So this is graph number 1 between 1 by u and 1 by v for real image formed by a convex concave mirror. Then what would be the second graph? Real image formed. Then the second graph would be what? First graph is real image. So second graph would be what? Graph number 2. Have you drawn graph number 1?
Yes, sir.
Graph number 2 is for virtual image formed by a concave mirror. You can see the difference here. You can see the difference here. The graph starts from this point and goes like this. Have you drawn these two graphs, my dear friends?
Sir.
Okay. Now
Completed, sir.
you will not be asked to draw these graphs, beta. If a question comes on this graph, they will show you a graph and they will ask you which is the correct graph for a real image or a virtual image. This is how questions would be framed. I'll see there would be some question that has come. Sometimes I will show you those questions as well. Have you drawn the graph number 1 and 2?
Yes, sir.
Here comes graph number 3. A convex mirror for a real object can only form virtual image, and this is the graph for virtual image formed by a convex mirror. This is again a graph between 1 by u and 1 by v. Remember, whenever there is a graph of 1 by u and 1 by v, it is always a straight line. Do we understand this? Yes or no? No, yes. We don't understand it, sir. Whenever there is a graph between 1 by u and 1 by v, it is always a straight line graph. Who is calling? Okay. Have you noted graph number 3, beta?
Yes, sir. Sir, once explain those graphs, sir.
You just have to draw them, beta. Don't have to explain. It's straight away. They are based on 1 by u plus 1 by v is equal to 1 by f.
Excuse me, sir.
Who's calling?
Sir, there is a disturbance in the class. Can you please wait for 1 minute?
Okay, who is calling? Who was calling? Everything okay? Other class? Still someone calling? Who can call on this call? Strange. Stranger things have happened in life. Okay. Is it okay now?
Yes, sir. It's all. Thank you.
Okay. Yes. See beta. 1 by u, 1 by v, it's a straight line, right? It's a straight line graph. It's as simple as that. Now we have already seen where you place the object to get a real image, where you place the object to get a virtual image, and you just put the values and you will get that straight line. Do we understand this? Everything that has been drawn, whether it's graph between u and v or graph between 1 by u and 1 by v, it is simply based on this equation. Do we understand this beta?
Yes, sir.
Simply based on this equation, nothing else. If 1 by u is confusing you, so what you can do, my dear friends, instead of calling it as 1 by u, you can call it as a, and instead of calling this as 1 by v, you can call it as b. Instead of calling this as 1 by f, you can call it c. So the graph simply becomes a plus b is equal to c. Your a is on the x-axis, your b is on the y-axis. It is a straight graph. Do we understand this straight line graph?
Yes, sir.
Very simple straight line graph. You just put the value of quantities, you put the value of u as f, you will get the answer where the image is going to be formed. It's as simple as that. Okay? Shall we move ahead? Yes, anyone having any other doubt?
No, sir.
No, sir.
Shall we move on to the next graph?
Yes, sir.
Now, to get a graph between u and v, it will be a bit more difficult because you have to get u in terms of v. No, not u in terms of v, but v in terms of u. Yes or no? So v would be plotted here and u would be plotted here. So you have to get v in terms of u. You can easily get v in terms of u and you will get the graph. Now, this is the graph for a concave mirror when the image is real. Now remember, whenever the image is real, the object should not be placed between 0 to f. Yes or no? Therefore, you don't see anything in this side which is painted yellow, because when the object is between 0 to f, the image is virtual. Do we understand this? And this graph will come in the form of a rectangular hyperbola. You don't know what is rectangular hyperbola. Any equation xy is equal to constant, and this equation will come in this form. This will become a rectangular hyperbola. This is simply maths, nothing else. So this is how the graph looks like. The graph between u and v for a concave mirror when the image is real. For virtual image, u would be between 0 to f. Do we get this? So it is just putting everything for real objects and real images. And this graph is going to be a rectangular hyperbola. Have you drawn this graph, my dear friends? Yes, beta? I'm showing you all possible things that can be asked in the exam. Not everything would be asked, but it is my humble duty to tell you everything that could be asked. Can I move on to the next graph?
Yes, sir.
So the next graph that you see is a graph between something has changed u and m, not v. U and m for a concave mirror? And if I may ask you, what type of image will be formed in this position? Look at the graph and tell me for what type of image this graph is drawn. It will be U and V, not M. Why it is written as M? It will be U and V. Sorry. It will be U and V, not M. U and V. Yes. Now looking at the position of U, can you tell me for which condition is this graph plotted? Between U and M. If I just say it M, U and M. For which condition is this graph plotted? As you can see, my dear friends, here the value of U lies between 0 to F. Yes or no? Do you see this? Therefore, this would be U and M graph for a virtual image created by a concave mirror. Do we understand this?
Yes, sir.
This is why and how did I get this? How did I get that this was for a virtual image? Because I looked at the position, look at the values of U. When U is between 0 to F, then I get a virtual image. Remember, the graphs are all hyperbolas. Do we understand this? Can I have raise hand from everyone that we understand this? Okay. Okay. Then I'll have the last graph. And if you can recollect it and tell me for what type of mirror and for what type of image this graph is drawn, I would be pretty happy. Only one case is left. Only one case is left. And this is a graph for a convex mirror, and it can only produce what type of images? It can only produce virtual images. They are not going to ask you graph between M and U. It's highly unlikely. What you are supposed to know is the graph between 1 by U and 1 by V, and the graph between U and V. Are those graphs clear to you, everyone?
Yes, sir.
The शुरुआत वाले 4 graphs are the graphs which are important, and you must remember them. And what is the way of remembering them? If the graph is between 1 by U and 1 by V, it has to be a straight line. If the graph is between U and V, it is going to be a hyperbola. Do we understand this?
Yes, sir.
Anyone? I will just wait here. Anyone having any doubt, please ask me. Up till here. Anyone having any doubt up till here, please ask me.
No,
Because,
sir.
yes, beta. No, shall we move ahead then?
Yes, sir.
Okay, now remember,
Sir,
whenever, yes, beta.
how we are drawing those graphs, sir?
Those are beta mathematical constructions. You just have to remember them. You understand how the graphs for 1 by U and 1 by V are coming straight line? Do we understand this? Yes or no? Do you understand how these graphs are coming straight line for 1 by U and 1 by V?
No, sir.
You don't understand it? Why this graph is a straight line? You don't understand why this graph is a straight line? What is the equation of a straight line? Y is equal to mx plus c. Do we understand this?
Yes, sir.
That's it. Here y is 1 by v and x is 1 by u. So it's a straight line graph. And then you put different values of u and v, you will get this graph. Okay, beta?
Sir, once explain that hyperbola, sir.
But it's a hyperbola. If you don't know the equation of a hyperbola, I can't explain this because this is completely maths. You just have to remember that it's a hyperbola, beta. Nothing else. You just have to remember that between u and v, the graph is a hyperbola. It's a rectangular hyperbola. It is not in your course even. So even if you have done the entire maths, you will probably get to know about ellipse, parabola, hyperbola. You will not get to know about rectangular hyperbola. You just have to remember this, that this graph is a rectangular hyperbola. You just have to see from where to where the graph does not exist, and in this yellow zone the graph does not exist. Do you understand this? Why it does not exist in this yellow zone? Do you understand why it does not come in this yellow zone? Do you understand
Yes,
this?
sir.
That is all that you need to understand. Because when a question comes, they might start the graph from the yellow region, so you know that that is not the correct graph. Okay, do we understand this, beta?
Yes, sir.
And then you need to understand that when u increases, when u increases, the value of v will decrease, and therefore the graph comes like this. That is the only two things that you have to understand here, beta. Looking at the shape of the graph, from where to where that graph comes, that is all that you need to understand. Nothing else. Nothing else here. I cannot tell you how this graph is traced or how this equation leads to this graph, because that is just purely maths, which is not a part of this curriculum. Okay, shall I move ahead?
Yes, sir.
Do you understand straight lines? Just remember straight lines. And this graph is a hyperbola. No one is going to ask you why it is a hyperbola. This is the equation of a hyperbola, sir. That is all that we need. And remember, I have already told you that I'll only tell you what you need to know. If I tell you that you do not need to know the reason behind it, you do not need to know the reason behind it. It's as simple as that. Because we are dealing with maths here, beta, and maths is immense. It's too much. We can't tackle maths here. Okay, shall we move on?
Yes, sir.
Okay. Now comes a very important point. Now remember, whenever you are dealing with questions in JEE Advanced, this is how and this is where they are going to trap you. And as my students, you should not get trapped, because if you get trapped, well, that is the end of the thing. Okay, now what we had seen, and if you remember the first thing that I told you, and the first thing that I told you was, if a ray is parallel to principal axis, which point, through which point does it pass? If a ray is parallel to principal axis, through which point does it pass? Are we there in the class, beta? I think students are changing places from first bench, they are going to second bench, from second bench, they are moving to first bench. What's happening? Everything is good? Is everything good? Fine. Can you hear me?
Sir, eyes are paining. That's why we went somewhat back,
Oh,
sir.
oh, oh. After the class, just tell me if I could change the color of the background. Maybe I can make it lighter. I mean, this white color hits your eyes. Is that so?
Yes, sir.
So I'll try to let me try it here. Can I let me try to change it to some other color. After the class, I'll do that. Okay.
Okay,
I think it might be a bit more shiny than it is supposed to be. Okay, I'll try to change the color and let us.
okay, sir.
Okay. Tell me what color suits your eyes, and we'll do that. Okay. So what did I tell you is when a ray is parallel to principal axis, after reflection, it goes through which point? After reflection, it goes through which point? Array? Simplest thing in the entire universe, yaar. Meanwhile, I'll just switch on the colors. Yes, yes, yes. Tell me, is this color better,
Yes, sir.
or shall I make it more halka, or is this okay? Hope it does not shine that much. Okay,
It's
chalo.
fine, sir.
Okay, I'll put it in this color. Yes. Coming back to the point, if the ray is parallel to principal axis, what happens to it? Which point through which it passes? We don't know.
Focus, sir.
Focus. But that only happens in the case where we call ray as parallaxial rays. What do you mean by parallaxial rays? The angle of incidence is very
Small.
small. If the angle of incidence is not small, as you can see here, this angle of incidence is not zero. It is very high, very big compared to zero. Now, when such rays fall on the mirror after reflection, they will not pass through focus. This B is not the focus. Do we understand this?
Yes, sir.
This B is not the focus. This B is not the focus. Please remember this. This point B is not the focus. Now, we have to find out where this passes. Let me call this distance as X. Let me call this distance as X. Now, how do I get the value of this X? It is very easy to see that from here to here, the distance is R, radius of curvature, yes or no?
Yes, sir.
Well done, sir. Then how do I get the value of this distance X? Again, this is an exercise in maths. Angles are given. This angle is theta. This angle is also theta by similar because the sides are equal. You can easily find the value of X using plane, trigonometry, and maths. That is not my intention of trapping you into. I will just tell you what is the value of this BP, where these rays meet, and the answer is R minus R by 2 cos theta. This is the distance of the point from the pole of the mirror, and I have not done anything extraordinary. I will just find it out using simple maths and applying a bit of approximation. Again, if I just show you that calculation, it is not going to serve any purpose. What you need to know is this is the answer. So if it ever comes, you must remember this. Now, if theta is very small, my dear friends, now you can see this. This is the actual formula. Now, if you can see beta, if theta is very small, or you can say approximately equal to 0, your value of cos theta will become how much, my dear friends?
1.
1. So R minus R by 2, your distance BP will become
R
R
by 2.
by 2, and therefore the image is formed at the focus. Do we understand this, everyone in the class?
Sir.
The first formula that I have written is for all types of rays. The second formula that I have written is only for parallaxial rays. Do we understand this? Yes or no? No or yes?
Yes, sir.
Pakka, sir? Will you remember this? Remember, how this has come is not what you must understand. You must understand this. This is how you get it. Can I move and give you one more pointer? These are all life-saving pointers, and you might find them in the examination hall, and then you will recollect, अरे sir ने बोला था ऐसा. Sir has already told us this. If this question can come, and I give these pointers every year. I've been giving I've been giving my students a sheet of modern physics, and I think it is here. Yeah, it is here. See, this sheet of modern physics, it has only two pages, and I've been giving this sheet from the last 7-8 years. And in this sheet, there are around 10 or 12 formulae, right? I gave this every year, and all these questions normally when it comes from modern physics, they come from this sheet. This particular year, what I have been doing for the past 7 years, it never came in the past 7-8 years. This year in JEE Advanced, a question came. You can see this point number, whatever it is, 7, 8. This point where they have this minimum kinetic energy. The same thing came in JEE Advanced of this year. I know you cannot see it. 7 years I've been giving this sheet. This year it came. So whatever I say, it may happen that they are going to come in one or the next year. Similarly, in this year, there was a question based on thermodynamics. I will show you that question where gas is coming from the lower end, it is going from the upper end, and there we had to apply something known as Bernoulli's theorem. But that Bernoulli's theorem has to be applied for compressible fluid. I have been doing that derivation and giving the formula to my students the last 8 years. The last 7 years, it never came. 8th year, it came. So please remember what I am telling you, because anything can come, and this is the next pointer that I am giving you, my dear friends. What happens if the rays are parallaxial? Rays are parallaxial. Rays are parallaxial, but not parallel to principal axis. Where is the image formed? And you may have this. Remember, this will never come in JEE Mains because this is out of the box for JEE Main. This type of question is going to come only in JEE Advanced. Now, if the rays, remember here the rays are parallaxial, the first thing, therefore the image has to be formed at focus. Do you see this, my dear friends? F. You see F there, right? But it is exactly not at the F, it has got some height. This height is what we are talking about, this height. And they might ask you, what is this height of the image that is formed? And in the examination hall, you cannot solve it. You have to solve it here now. And again, I'm not telling you how to solve it. This is very simple. You can see this triangle here, this yellow triangle here, and you can see that this is a right angle triangle. From there, you can find out the value of tan theta. Yes or no, my dear friends?
Yes, sir.
What is the value of tan theta? Tell me, bacha. Tan theta will be equal to f dash divided by fp. So from here you can find out the value of this f dash. That will be equal to tan theta multiplied by fp, and fp is nothing but the focal length. Now if the rays are parallaxial, therefore this tan theta ka value becomes equal to theta. This is plane trigonometry. This is plane trigonometry. This is plane trigonometry. This is plane trigonometry. So my height of the image f dash becomes f times theta. Please keep this in safe deposit somewhere. It might come this year, the next year, where you are going to give your JEE Advance. I hope you have noted this down. There are a few more pointers that I'm going to give you, and then I'll give you entire formulae at one place. And once we are done with everything, then we will move on to questions, so that whenever this question comes, whatever they ask, you should be able to solve it and find out the correct answer. Has everyone noted this down, bacha? Remember these pointers? Very important pointers I have given you today. If you are lucky enough, you might get a question straight away this year, or whenever this question comes in JEE Advanced, you can remember that sir had already given us this question, but that year did not come. So on that note, I will end today's class. I hope everyone has noted this down. Yes or no?
Yes, sir.
So we'll meet again in the next class, and the background thing is okay now. It is not hurting your eyes. So I'll keep this as a background. I just changed it 2 or 3 days back. I thought that white would look better, but I think white just shines too much. So I'll keep them on the dull color. I will see you in the next class. And if you have any doubts, you can always come up to me.
Sir.
Take care. Have a nice day, beta.